Joins can be confusing when you're starting out in SQL. Inner, left, right, full, which one to use, right? Today we'll break down all four, step by step with beginner-friendly examples that you'd remember. We'll also think like a data analyst and answer real business questions using joins. So without further ado, let's dive right in. Meet Sophia. She owns a small coffee shop. She stores her data in a relational database. For today's illustration, we are interested in two tables. One is the customers table where she stores information about customers, and the second is the orders table where she stores information about orders. A join clause is used to combine rows from two or more tables based on a related column between them. As a data analyst, your job is to query the tables and join them where needed to answer the business's questions. Without joins, you'd only know who the customers are or what orders were made, right? But never both together. But the real value is when you can combine them in a meaningful way, and joins help us in achieving just that. An inner join only shows rows when there's a matching value in both tables. In our case, where the customer ID exists in both the customer table and the orders table. You can visualize it as an overlapping part of a Venn diagram. If there's no matching on both sides, that row is left out completely. So when do you actually use it, right? When the related information you need is stored in the other table and missing data is irrelevant. For example, let's say we want to see only customers who have placed at least one order. We don't care about customers who haven't bought anything yet, right? They won't appear in our results. Here's the scenario. The marketing team wants to send a thank you email, but only to customers who actually placed an order. Think about it. Our main list is the customers table because we need names and emails. But if we just pulled that table, we'd be emailing everyone, even people who never bought anything. So we need to match our customers with their orders using customer ID as the link. And since we only care about customers who do have a match in orders, we'll use an inner join. And that way, anyone without an order is automatically excluded. The SQL query would look something like this. Now, let's break that down. First, you have select c.name, c.email. Here, we are telling SQL which columns we want in our result. Name and email from the customers table. So the C that you see, it's basically we are using the alias C that we gave to the customer table. Next, we tell SQL where our data is coming from and how to combine it. We start with from customers as C, that's our main table. Then right after it, we add inner join orders as O. Think of the inner join as the glue that connects both tables, but only where the matches exist. Finally, the own clause is followed by c.customer_id equals o.customer_id. This part is the rule for how the glue works. It says only join rows where the customer ID in the customers table matches the customer ID in the orders table. The result, we get only the customers who actually placed at least one order. Anyone who hasn't ordered is left out. And this is perfect for our marketing request because we only want to thank the customers who have actually bought something. Now, let's talk about the right join. Think of it as saying I want everything from the right table and only the matching rows from the left table. In our example, the orders table is on the right and the customers table is on the left. That means we are keeping every single order, even if there's no matching customer, and only pulling in customer details when they exist. If you look at the Venn diagram, the big blue circle on the right is the orders table. That's what we keep entirely. The overlap in the middle is where an order has a matching customer, and the blue only section, it shows orders without a matching customer, like guest purchases, right? So why do we use the right joins? It's perfect when the right table is in your main table, the one you don't want to lose any rows from. For example, you want to see all orders, also including the ones made by guest customers who don't have an account. So the right join ensures those guest orders still appear in your result with the customer info fields left blank. Now, here's the scenario. The sales team wants a report of all orders, including those made by guest customers who don't even have an account in the customers table. Think about it. Our main list here is the orders table because the goal is to make sure every single order is included no matter what. If we only pulled customers, we'd completely miss the guest orders that don't have a matching customer record. So We'll start from orders and match them with customers using customer ID as the link. And because we want to keep everything from orders, even when there's no matching customers, we'll use a right join. That way, guest orders show up too. The customer detail will just be blank where there's no match. So the query would look something like this. Let's break this down step by step. Since we already covered the general parts of a join, here's what's important for right join. The right table here is orders, so every single order will appear in the result. The join will try to pull customer details where customer ID matches, but if no match is found, those columns will be blank. This way, guest orders or orders with missing customer records are still captured in the report. And the result, we get a complete list of orders, both from registered customers and from guest customers, so nothing is left out. Think of a left join as a mirror image of a right join. Instead of keeping everything from the right table, we now keep everything from the left table and only bring in the matches from the right table where they exist. Here's a neat trick. A left join is basically the same as a right join if you just swap the positions of the tables in a query. Alright, we have seen inner joins for matches only, right? We have seen left joins for keeping everything from the left table and right joins for keeping everything from the right table. Now, what if you don't want to leave anyone out? And that's where a full outer join comes in. Think of it as casting the widest possible net. You keep everything, every row from both tables. Where there's a match, the data comes together. Where there's no match, you still get the row, but with empty fields from the missing side. In this example, customers and orders are combined. So we see customers who placed orders, customers who never placed an order, and even orders made without a matching customer record, right? It's the ultimate no one gets left behind join. Now, the operations team needs an end-of-year reporting showing everything, all customers, even those who have never ordered, and all orders, even the ones with no customer account attached. We start from both tables at once, and that's the beauty of a full outer join. It doesn't care which table is the main table, because we are pulling all rows from both sides. Matching rows are stitched together where possible, and anything without a partner stays in the list with blank spots for the missing info. So the query looks like this. Full outer join is the glue here, right? It says give me every row from both sides and match them where customer ID aligns. If there is no match, the unmatched sides column just shows as null. And finally, this is different from left or right join, where one table always wins, right? Here, both tables are equally included. Executing this query would give the following result. Customer 3, 4, and 5 never ordered, but they are still in the list, right? Orders 103 and 105 belong to customers, but orders 106 has no customer record, still included. For matches, you get complete rows with data from both sides. In short, full outer join gives you the most complete, nothing hidden view of your data. So, after exploring inner, left, right, and full outer join, here's what it all really comes down to. Know your main table, which sides rows you absolutely must keep in the results. Decide what to do with unmatched rows. Do they really matter to your question, or should they be filtered out? And finally, understand the relationship. Are you looking for only matches, only one side plus matches, or every possible record from both sides? Once you answer these three questions, picking the right join becomes simple. And with these joins in your toolkit, you can tackle almost any scenario that involves combining related data from multiple tables. And you'll always be confident you're pulling exactly the rows you need.